In this video, we're going to review the process of protein synthesis. So remember, in protein synthesis, we're going from DNA to RNA to a protein. And the first step, the DNA to RNA step, is going to be a process called transcription. All right. Now remember, A is going to go to T if we're talking about DNA. A is going to go to U if we're talking about RNA. And C is always going to go to G. So since we're going from DNA to RNA, we're going to be going from A's to U's. You're not going to use T when you're doing transcription, when you're transcribing. All right, so here's my DNA, and you can tell it's DNA because it's got T's and it's double-stranded. And this provides my code. All right, now I like to think of it like a cookbook. And inside that cookbook, I have recipes to make various foods. And in this case, I'm going to call these genes. So you have genes that are recipes to make various traits and proteins for you. And what I'm going to do is, in order to read this book, I first have to open it up. So I'm going to use an enzyme, and that enzyme is going to come through and open up the DNA so that I can read it. So I'm going to take this recipe, and because this is a big book and I don't really want to mess it up, I'm going to transcribe or copy the recipe onto a little scratch sheet of paper. So remember, a scribe is somebody that copies something down. And so what I'm doing is I'm going from the DNA to mRNA. mRNA is my little message, which is my scratch sheet of paper that I can take with me and get rid of whenever I need to. So I'm only going to use one side of the DNA as a code. And I'm going to use enzymes to get all this stuff done. And I'm also going to need some RNA nucleotides because that's what's put together to make my mRNA. And so based on the complementary base pairing rule, the enzyme is going to take those RNA nucleotides and put them together based on the DNA code to make a copy of this code. And it's going to go down and it's going to transcribe every codon from that start codon all the way to this stop codon. And now I've made my mRNA. The mRNA can then separate and go off to the ribosome where it can become a protein. So we've already gone from DNA to RNA in transcription. Now we're going to go from RNA to protein in translation. And I like to think of it as, when I'm going from DNA to RNA, I'm just making a copy. I'm not changing the language in any way. But going from RNA to protein, that's like going from the nucleotide language to the amino acid language. So it's a completely different language, and that's why we're having to translate it. All right, so remember, I went from the DNA to the mRNA. I have my little scratch sheet of paper. Now I'm going to take that and actually make the food, or in this case, the protein. So I need some ingredients, which in this case are going to be amino acids, because that's what make up proteins. I need something to carry those and measure out all of those different ingredients, and that's going to be my T, or transfer RNA. You could also think of them like the trucks that bring the amino acids. And all of this stuff is going to go to the ribosome, which is like my mixing bowl or my factory. That's what puts everything together. So here's my mRNA strand, and it's going to go over and get bound by this ribosome. And then I'm going to have some tRNAs, and if you notice, the tRNA has a codon. This is called an anticodon that matches up with the codon on the mRNA. And this is how it knows which amino acid to bring. So each tRNA is going to bring a different amino acid, and it's going to match up based on this codon that it has attached. So this tRNA is going to go into the ribosome, match up with the mRNA. The ribosome will move down. Another tRNA will come in with a different amino acid based on its anticodon. It's going to match up. Ribosome is going to move down. And notice the ribosome has put together the amino acids. So remember, this ribosome is basically an enzyme that is putting together amino acids to make this protein. And so the next tRNA is going to come in, the ribosome is going to do its thing again and create that peptide bond. That first tRNA is going to go away where it can go get another amino acid attached. And then in comes a stop codon. And this is going to tell the ribosome it's time to stop making this protein, because when it shifts down, there's no amino acid to attach. And so the ribosome is going to let go and go away. The tRNAs and stop codon are going to go away. The mRNA can either go make another protein or it'll get destroyed. And all I'm left with is my protein. Now this is a pretty small protein. Normally these would be, thousands of amino acids long, but that's the basics of how that works. So remember, DNA, RNA, protein. DNA to RNA, I'm transcribing. I'm going from A's, T's, C's, and G's to A's, U's, C's, and G's. And then when I go from RNA to protein, I'm translating, and so that's where you're using that amino acid codon chart, and I'm going from A's, T's, C's, and G's to all the different amino acids. And that is protein synthesis.